I am on a personal mission to bring freaking cool holiday LEDs to the masses. You don't have to spend thousands of dollars or have a degree in computer programming to have the coolest multicolored LEDs in the neighborhood. If you can hang Christmas lights and have a computer and fingers, you can do this. Ready? Go. First, let's talk about the LEDs. When you see people have those fancy light shows on their houses, they're using what's called individually addressable LEDs. That means each little light gets assigned its own color and brightness. If you want a lot of really good, really technical information about all the different kinds of addressable LEDs, check out Hookup Rob's video. I'm a simple man, so I'm going to keep things simple. The first choice you need to make when choosing your awesome new LEDs is, do you want strings or strips? The strings look like this. They're the most like traditional bulbs. Each little bulb is 3 inches apart. They come in 5-meter strings, which is 16 feet for all you heathens in America. And they're waterproof. You can get them in 5 volts or 12 volts. And they usually cost around $12 to $15 per string. Those are the ones that I have on my house. The other option is strips. Strips are flat. Some are waterproof, some are not. And they come in a whole wide variety of LED density, meaning how far apart are the LEDs. You can get them all stacked right next to each other, or you can get them spaced out so that there's about 150 LEDs in 5 meters. The more LEDs you have, the more current you need, and the more expensive they are. What you choose just depends on what look you want. Another thing to consider when choosing your LEDs is how you want to mount them. With the strings, you could just use nails. That'd be the cheapest, but it wouldn't look very good. I used a vinyl channel for mine. The channel costs about $7 for 12 feet. But that required some drilling and maybe painting if they don't sell a color that matches your house. This is a piece of the J channel with the LED strings. I think it looks pretty good, and it does a nice job of hiding the wires. You mount it so that the lights are facing down, and then you've got these slots where you can put screws through into the fascia board on your house. The downsides are, first, you have to actually drill these holes individually yourself. They're 1/2 inch or about 12.5 millimeters, and you need one hole every 3 inches. The other downside, this was white originally, so I had to spray paint this to match my house. That was 2 years ago, and since then they've started making it in a lot more colors. So if you choose to do this, hopefully you can find a color that'll match your house. But either way, you still have to drill those holes, and that takes a lot of time. But if you like this look, this is a good option. If you go with the strips, you could use this aluminum channel with a light diffuser. It looks nice and costs $2 to $3 for 3 feet. Some folks have used PVC pipe and slid the LED inside of that. That costs about $2 for 10 feet. I was kind of surprised to see the LEDs shine through the PVC pipe, but they do. It actually works pretty well. If you go with the waterproof strips, you may not need anything else for mounting if they have a good adhesive backing and you have a good, flat, clean surface to stick them to. Here's a breakdown I put together of the price per foot for strings and strips and different mounting options. Until I made this table, I thought I had done a really good job of doing the cheapest method possible with my strings in J channel. After seeing this cost breakdown, I bought some that are waterproof with the adhesive backing. I'll put them up and see how long they last. When they fall off the house, I'll update the video description and let you know how long they lasted. Here's some examples of how the different installation methods look. just an example of a couple more of the mounting systems. This is some of that aluminum channel with the diffuser on it. This actually is really cool stuff. This, believe it or not, is wire management tubing from Ikea. And then I just stuck the LEDs inside of it, and it really diffuses well. It looks super cool. And then this last piece is just a piece of that thin-walled PVC pipe. And you wouldn't think that the LEDs would shine through very well, but they really do. It has to be dark to really see them well, but it looks nice. I mean, definitely there's some places where that's going to be the right thing to use. Aluminum channel with the diffuser, Ikea cord management tubing, and thin-wall PVC. Let's talk for a minute about LED voltage. For all practical and economical purposes, all the individually addressable LED strips are 5 volts. Technically, they're WS2812. Yes, there are some 12-volt options, but they are either not really individually addressable, like the WS2811s, which are actually tri-addressable. That's a word I just made up. It means you don't get to tell each individual LED what color to be. You get to tell 3 at a time what color to be. They're nice, and they're not too expensive, but they're not individually addressable. There is another newer 12-volt option for LED strips, but they're quite a bit more expensive. Those are the WS2815s. Those are the ones that cost like $50 for a 12-volt string versus $15 for a 5-volt string. So if you're going to get strips, get WS2812s at 5 volts. The strings, however, do come in 5 volts or 12 volts. That's because the strings are actually WS2811s. But unlike the strips, the strings are individually addressable. 12-volt strings are a little more expensive than 5-volt strings. The difference is about $2 per 5-meter string. The advantage of 12 volts is this. You lose a little bit of voltage with each LED because each LED adds a little bit of resistance. Eventually, the 5 volts that you started with will have dropped too low to produce accurate colors. The solution for the 5-volt voltage drop problem is to run a parallel set of wires from your power supply and inject power at each end of your LED strip or string. All of these LED strips or strings give you wires to easily connect to for injecting power. It's almost like they knew you were going to need to do this. These are the strings. You can see they look like little bulbs. If you look closely, you can see these are 12 volts. It says right there, 12 volts. I also have some that are 5 volts. They don't have a label that says 5 volts. If you connect 5-volt lights to 12 volts, you're going to be buying some new LEDs. These are the extra wires that they provide for you to inject voltage. And the same goes for the strips. They all have 2 extra wires at the beginning and the end of each string or strip of LEDs to help you inject voltage. Another important thing to see here is that all these LEDs are directional, meaning when you connect the controller, the signal that tells the LEDs what color to be travels in one direction. It can't go the other way. They all have arrows to tell you which way the signal needs to go. So when the arrow's pointing that way, you connect your controller to this end. Running the extra wire and making the connections to inject power will cost you about $1.50 per 5 meters. That's about the same as the price difference for the 12-volt strings. And those don't require any extra power injection, so that means less labor for you. So if you're using strings, it's probably worth it to get 12 volts. With strips, the price difference between 12 volts and 5 volts is a lot bigger. Now let's talk for a minute about power supplies. If you get 5-volt LEDs, you need a 5-volt power supply. If you get 12-volt lights, you'll need a 12-volt power supply. The size or number of amps that you'll need depends on how many LEDs you plan to run from that power supply. If you just do the Google, you'll find recommendations for 60 milliamps per LED, but that ain't the whole story. These LEDs are going to be flashing and dimming and showing all sorts of colors. My simple rule of thumb, yeah, I said simple, which hasn't failed me yet, is 1 amp per 50 LEDs. So figure out where you want to put your lights, which kind of lights you want to use, how much length you're going to need, then figure out the total number of LEDs, roughly, and divide by 50. That'll give you a good estimate of how many amps you're going to need from your power supply. You can get the wall wart style. Those are usually 1 to 3 amps. You can get these in closed corded style. Those are usually 5 to 10 amps. Or you can get this bare metal style, which can be anything from 1 to over 60 amps. I've used some of each. They all work fine. So there's 3 kinds of power supplies. You've got these kind that plug into the wall. These are pretty easy to find in 5 or 12 volts, and they're usually 1 to 3 amps. If you need more than 3 amps, you're going to need something bigger than this. The next step up is something like this. These you can usually get somewhere between 5 and 10 amps. An important part about both these kinds of power supplies is that they use these barrel connectors. This is one of those big bare metal power supplies. This one's 5 volts, 60 amps. You have to connect it to a power cord like this, and then these terminals here where you connect plus and minus for the 5 volts. This one is a 12 volt 1 amp. So these bare metal ones go all the way from 1 amp to 60, maybe even more. These bare metal kinds will have screw terminals instead of those barrel connectors. That makes it a little easier to just strip wires and connect things. If you do get a power supply that uses barrel connectors, you can get these sort of adapters. So you can put wires in one side and it'll connect to a barrel connector like that. This one has push buttons, but most of them have screws. By now, you should have a pretty good idea of what you want your house to look like when it's all decked out in LED awesomeness. The next thing to talk about is how are we going to actually make all those fancy colors. For that, we're going to use a simple $3 controller called a Node MCU and some free software called WLED. This is a Node MCU. It's a little circuit board with a USB connector and a whole bunch of pins for connecting wires. If you've never touched a circuit board like this, it's okay. Don't give up now. Stick with me. I'll walk you through it. You can do this. It's not going to hurt you, and you're not going to hurt it. You can pick it up, touch it, shake it around. You're not going to break it. The first step in turning this little board into an awesome LED controller is to download WLED. You can just go to WLED.me and then releases, and the one on top will be the newest version. The Node MCU uses the ESP8266 chip. Don't worry, there's no test. You're not going to have to remember that. But that tells you which of these files you need to download. So download the file that ends with ESP8266.bin right here. Save it somewhere where it'll be easy to find, like your desktop. Next, we need a program that will copy that file onto our Node MCU. For that, we're going to use ESP Home Flasher. There's a version for Mac or Windows. Grab the one that applies to you and download it. When you first start up ESP Home Flasher, you may get a warning message that says, "Are you sure you trust this software?" Mac does the same thing. I promise it's safe. Next, grab a micro USB cord. It's the itty bitty one. Plug it into your computer and then plug it into the Node MCU board. You may get a light to flash, you may get a light that stays on. It doesn't really matter. Now in the ESP Home Flasher, hit this refresh button and then hit this drop down box and you should see a COM number here. Now depending on what else you have connected to your computer, you may see more than one of these. It does a pretty good job of figuring out which one is the Node MCU and putting that number at the top. But don't worry, if you pick the wrong one, it's not going to hurt anything. It just won't work until you pick the right one. So I'm going to select my COM29, and then you go to Browse, and then find the bin file that you downloaded, which is right here. Open that, and that's it. Now you hit Flash, and there it goes. This will take 30 seconds to a minute. Done. Flashing is complete. That wasn't so bad, right? Didn't even explode. As soon as it says Flash Complete, you're going to need a Wi-Fi connected device. So a laptop or a phone or a computer that can connect to Wi-Fi. Look for new Wi-Fi networks and you'll find one called WLED AP. Connect to that. So the password is WLED, all lowercase, then 1, 2, 3, 4. Sure. Your browser might automatically find and connect to the WLED user interface, but if it doesn't, then open up the browser, like Firefox or Chrome or whatever you use, and in the search bar, type 4.3.2.1 and hit enter. And there you go. You're connected to your WLED board. Now you could control the Node MCU and the LEDs through this interface right here, but most people won't want to do that. So if you are most people, then click Wi-Fi settings and you get this page. Here, you need to put in your Wi-Fi name and password. Then go down here to this box that says HTTP and give it a name that will be easy for you to remember. It's probably a good idea to give it a name here that has something to do with where you're going to put it. I'm going to name it DrZzs. That's what my friends call me back home, is DrZzs. That's it for this page. When you've done that, hit save and reboot. Now the Node MCU is going to be able to connect to your Wi-Fi. So give it a minute, and then in the browser, type what you put in the box next to .local. You probably need to include the beginning, which was http:// and then mine was WLED-DrZz, D-E-R-Z, .local. And there it is. This is the WLED web interface. You can do pretty much everything you need to here, but this probably isn't where you'll do most of your LED controlling. Probably the more common way that people are going to want to control their lights is using the WLED app. It's a free app. It's available for Android or iOS. Go to the App Store, download it. When you open it up, you won't see all this. These are all of my WLED controllers. Yours will be blank. To find your new Node MCU with WLED on it, you hit the plus in the upper right corner, then Discover Lights. Give it a second to find a bunch of new lights. Well, probably will only find one. And then hit the check mark. Back on the front page, you'll have a new entry that'll just say WLED Light. Perfect. Under where it says WLED Light, it will also give you the IP address. If putting in the name that you chose, .local, didn't bring up the web user interface, then typing in that IP address will. So when I put that IP address up here, it takes me to this interface, even if .local is not working. Now that we've got WLED loaded on our Node MCU, we're ready to wire it up to the LEDs. Whether you're using strips or strings, they both come with this kind of connector at the beginning and 2 extra wires for positive and negative. So to connect this to this, we need some extra wires. These are jumpers that have a female end and a male end. Because we chose the Node MCU, we've got these pins ready to go. No soldering required. In the lower left corner, there's a pin that says V in. That's where we're going to put 5 volts. So I'm going to use a red jumper for that one. Next, we've got G. That's for ground. We're going to connect a white wire to that one. And then the signal that goes from the Node MCU to the LEDs to tell them what color to be connects to D4. Like that. Now we can connect these jumpers to our strip of LEDs. 5 volts to red, white is ground, and green is our data. 5 volts, ground, data. These 2 wires are where we're going to connect our power supply. So get your wire strippers or your fingernails or your teeth and expose a little bit of that wire. And then because I'm going to use a power adapter with a barrel connector, I'm going to use this adapter. Red's going to be positive. That's how it'll look. You've got 5 volts in ground and data connected to VIN, ground, and D4. You've got 5 volts here, ground here, and data in the middle. And you've got it connected to a female barrel adapter. Sometimes the wire colors are different. Just different manufacturers use different colors. You can always check on the LEDs themselves, and it'll tell you 5 volts is on that side, DO, which is data, is on the inside, in between the two, and then ground is on the outside. Same here. 5 volts on one side, data in the middle, and ground on the other side. Now with it all wired up, we'll connect our power supply. There we go. That's not so bad. If you want to make these connections more secure, add some electrical tape here or hot glue. And if you want to enclose everything, you can use something like a soap dish. Drill a hole for some wires to come out, and then just bundle up all this and stuff it in there. Something like that. You get the idea. I thought I'd better show you an example of how to wire up 12 volt LEDs because they are a little more complicated than 5 volt. And that's because if you connect 12 volts directly to your Node MCU, in most cases, it will go poof. Some of them say 12 volts is okay, but for the most part, you're better off using 5 volts so you don't damage it. So that means you need something like this. This takes 12 or up to 24 volts and converts it to 5 volts. This does the same thing, it's just a different style. I like this one because it has the screw terminals, so it makes it easy to connect wires. They both output 5 volts, 3 amps, and the price is about the same. this one might be slightly cheaper. So how do you wire it up? Well, first, this 12-volt LED manufacturer was kind enough to shift around the colors for us. So most of the time, red is going to be your positive and white or black is going to be your negative. That's not the case here. If you look closely, you can see 12 volts, D, and then ground. So in this case, white is the data and blue is the ground. So just be mindful before you make any connections. Make sure you can verify which is positive, which is negative, and which is data. So this is coming from my 12-volt power supply. Red is positive, goes here to the input positive. White is negative, goes to the input negative. Then I've connected these voltage in wires for my LEDs to the positive and negative. Red being positive, blue being negative. Now on the output side, I took a couple of jumper wires, cut them off, stripped them back a little, and then connected blue to negative and red to positive on the 5-volt side. Red then goes to VIN on the node MCU, and blue goes to ground. Then the last wire that I have to connect is the one from D4, which is the data pin, going to white on the LEDs. The most important thing to know here is that you've got to have a common ground. Inside this box, this ground is connected to this ground. So this will work fine. I could also just connect this blue jumper to the blue on the LEDs. That would work too. So then when we power it on, there you go. Worky, worky. And no smoke. Well, that's it. That's a pretty good summary to get just about anybody started with their own custom holiday LEDs. But that's far from all that you can learn. In the next video, I'm going to go into more detail about WLED and what you can do with the app, like set different effects, make your own custom effects, set timers, and control it with Home Assistant. That's all for now. As always, thanks for watching. Till next time, adios. If you need help or want to chat with me or others who also enjoy projects like this, you can find us on Facebook and Discord. If you like what I'm doing and you want to support me, you can use my special product links in the video description, or head over to Patreon, or just like and share my videos. That's easy. If you like this video and you want to see more like it, this box will take you to a playlist of some of my favorites. In addition to videos like this, I also do live streams every Sunday. This box will take you to a recording of the latest live stream. That's all for now. Adios.